Let's talk about graphs of motion. There's two types of graphs that you're going to have to make for physics involving motion. The first one is distance over time, and we know distance over time really equals speed or velocity. The other one is velocity over time, and of course you know that velocity over time is another way of saying acceleration. Okay, well, let's look at how these graphs are going to look. Okay, first let's look at a graph of a constant velocity. Okay, in this case we're going 5 meters per second. Okay, so if we go 5 meters per second for 4 seconds, the first second we're at 5 meters, the second 10, third second 15, and the fourth 20 seconds. So I just draw a nice straight line. Okay, and again I've got a constant velocity, right? My velocity is increasing at 5 units per second, okay? So in this case, if we look at the graph and we analyze the slope, the rise over run, what the rise over the run is telling us is that a slope of 5 here equals 5 meters per second, okay? One point about graphs, when we do motion graphs, we always want to put time on the x-axis and distance or velocity or speed on the x-axis, on the y-axis. So time is always on the x, okay? So just make sure you always do that when you're doing your graphs, okay? Well, let's look at a graph of acceleration, and here we have the acceleration of a free-falling object, okay? So it's the acceleration, the force of gravity pulling it down, okay? So on this graph, I'm going to start with, starting at 0, the first second it's going to go about the same to 5, but I know acceleration starts slow and then steadily increases. Okay, after 2 seconds, I'm up here at close to 20, at 3, close to 30, and at 4, I'm way up here, close to 80. Okay, so notice here, my velocity is not remaining the same. My velocity is increasing, and it's increasing at an increasing rate. Okay, how can I calculate the velocity at any given point on that acceleration curve? Well, for any point, I can draw a tangent line, and that'll tell me what the velocity is at that specific moment. So calculating from a tangent line, the rise over run will tell me the specific velocity at that point. Okay? All right, so that's how we calculate distance over time graphs. Now let's look at a graph that would involve velocity over time. So I need to change the units on my y-axis. So we're not looking at distance over time. This time we're looking at velocity or speed. And remember, speed and velocity are, I'll say, velocity is what? Meters per second. Okay? So now, with my two sets of data, they're going to look a lot different. Okay? So on this one, I've got a constant velocity of 5 meters per second. So I'm going to come over here to 5, and I'm going to stay at 5 meters per second. The velocity does not change. So in this case, the velocity or slope, the acceleration is 0. I have a constant velocity which equals 0 acceleration. Okay? Now let's look at the falling object. Okay? Here I've got the object was increasing, right? But the acceleration is constant. The acceleration again is 9.8 meters per second squared, which is almost 10. So if I draw that line, after 1 second, I'm at almost 10. At 2 seconds, I'm at almost 20. At 3 seconds, I'm at almost 30. Make sure I get my graph correct. And at 4, I'm at almost 40. 4 and 40, right there. So if I draw this, now notice I have a straight line that's increasing, and it's increasing at about 9.8 meters a second. That's the increase every second in velocity. So when I graph velocity versus time, if I have something that's accelerating, what it shows me is it shows a constant increase. Okay? If I have something at a constant speed or velocity, it shows me something that's not changing. That speed is remaining the same. The slope is 0. So these are two graphs that you're going to have to use and calculate in physics.